All right, back here with another example, or a few maybe, who knows, on discrete probability distributions. I'm not sure if I really emphasized the discrete on it earlier. Sorry about that little hiccup. If you saw that video, there's an issue with the rounding error. I forgot to double check it for the master class. I think it's fixed in your class, but let me know if it isn't. So anyway, find the standard deviation of this probability distribution. Give your answer to at least 2 decimal places. Well, we'll see how this goes. So I'm going to grab the data here and go back here. I don't think these are shared. Let me put them there. Okay. I'm going to paste this in here, zoom in a little bit. So here's where this relates back to what we were doing previously. The first step really is that I need to find the mean, and then after I find the mean, I need to find the deviations, square those, and do some work as it relates to the formula here. So we'll do x minus mu, square that, multiply it by p of x, sum those all up, and take the square root to find our standard deviation of our discrete probability distribution. So back over here for this. So finding the mean, x times p of x and I'll do this cell times this cell and double click down. I do kind of like to check that these add to 1. They do, so just in case. So now my mean, mu, is the sum of these. So this is 1.95. So now the deviations. And I kind of like to do this in a couple of different steps. So I'll do x minus mu for each one. And what I'll do is take x and subtract from it. And I like to just type in 1.95. If I take this value and subtract this one, I need to lock this in with dollar signs, at least this one, so that when I click down here, it does 2 minus 1.95 and 3 minus 1.95. Sometimes if you don't lock it in, it'll do 1.95, then it'll subtract this one, and this one. So it'll be negative 1.95, 1, 2, and 3. So these are what we call the deviations, and then now we'll square those. I like to do this in 2 steps, just because Excel's doing the most of the work. And sometimes people forget to square the right thing. So if you don't use the grouping symbol, you might just square the last one. And so we've got those. Now we have the deviation squared. So now we do the deviation squared, x minus mu, quantity squared, times p of x. Otherwise, the probability doesn't really come into play here. So that is this multiplied by the probability that it occurs. And I do want these to slide down, so I'll just double click this. And then now my standard deviation is technically the square root of that sum. So I'll find the sum really quickly. And then I'll do the square root of the sum. I forgot I put this on here earlier. The sum. And so sigma, the standard deviation, is the square root of this sum right here. And we'll round this to 2 decimal places. Again, going against some of the rules I gave you the other day. 1.07. Let's highlight here. And oh boy. Well, there it is. You're going to wonder if I'll get any correct here. So, we tackled one like this earlier again. Copy this over. See, are all of these between 0 and 1? And do they add to 1? Finding a mean here. A mean, again, we got it just a little more complicated. Round your answer to 1 decimal place. We'll try this for redemption here. Maybe. X and P of X. So X times P of X. I'll zoom in some, a little hard to see there. So we have our outcome times its probability. And those, the mean mu, will be the sum of these. Again, hit equals, grab the data points, add them all up. And round to one decimal place. It looks like 2.69 should go to 2.7. Okay. Another one, we're finding the mean. Another probability distribution. Here it says among Western Washington University students, 55% have no tickets, 35% have 1 traffic ticket, 5% have 2 traffic tickets, and the other 5% have 3 traffic tickets. Find the population mean and the population standard deviation of the number of traffic tickets. So we'll say our X's here. These are the outcomes. So no traffic tickets, 1, 2, and 3. The associated probabilities. 0.55, just going from 55%, making it a decimal value. 35%. 5%. Tempting to put it as 0.5, but it's actually 0.05. Remember, we're dividing by 100. So now, finding the mean, it'll be X times, it'll be X times P of X. And the mean, mu, will be the sum of these. And 6/10. So I'll do X minus the mean. Zero minus 0.6. I like to type it in there because it's a little bit quicker. Take those deviations and we square them. If you want to do this all in one, you can. If we add these up, they should get, well, not necessarily close to 0, because now we have the probability taken into account. But we need to square these to get rid of the plus and minuses, add up all those deviations. Now we multiply them by the probabilities. Those deviations squared, X minus mu, quantity squared, times P of X. So that's the deviation times its probability. Find the total there. Well, I think I did the wrong thing here. I don't remember what it was. Okay, well, I'll go back to the drawing board. I might have had the right thing. It was. Who knows? I think I copied instead of pasted. Or pasted instead of copied. Okay. Take the square root of the sum of all of those deviations squared times the probabilities. And enter some answers here. Round to 2 decimal places. 0.6. Looks like it's pretty precise. And then the standard deviation is 0.8. And there we go. All right, there's a couple more questions, but they really fall kind of in the same vein, so that should be more than enough to get you going through 3.3. The discrete probability distributions, working with those maybe as tables, finding the mean, the standard deviation, if it is in fact a probability distribution, and all that good stuff. Let me know if you have any questions. Thanks for watching.